going to talk about a different kind of gas law. In these next gas laws, we're going to have things changing. We're not going to have a gas in a container under set conditions. In these, we're going to be varying the pressure, volume, and or temperature. The first one is Boyle's law. And in Boyle's law, we assume that temperature is constant, and we're just letting the pressure and volume change. So a lot of these are really intuitive. You probably already know the answer to this one. If I take a gas and I compress it, what happens to its pressure? Well, its pressure will go up. And if we want to calculate how much it goes up, we could use this equation. The ones are for before we compressed it. So in other words, the pressure here and the volume here. And then the 2's are for after. So I have a volume 2 here, and I could calculate the pressure 2. Again, in this case, I'm assuming temperature does not change, so it's not in the equation. Also, the moles of gas are constant. That just means it's a closed container. Let's look at how this works. Here's my container. I'm going to add some gas to it. A little bit more. It needs to kind of move around and randomize. I'm going to adjust a setting so that the temperature cannot change, and we're going to see what happens. Now I'm going to compress this gas and see what happens to the pressure. And so if I'm watching pressure, remember pressure is caused by the containers hitting, or the molecules or atoms hitting the container wall. And think about it as like pushing against that wall every time they collide. So if you want to see what's happening with the pressure, I would choose a side of the container wall, not the bottom because that one's going to change, but like this side, and look at how often it's being hit by the different the gas particles. So if you look at that for a minute and how often it's being hit, then I'm going to change the volume. I'm going to compress this gas and look at how much more often it is being hit. You can also see the pressure on this gauge change. I'm going to do the other way around. I'm going to let it expand. It was around 19, now it's at 6 to 7. Now why does that occur? Well, just because when they have less space, they're going to hit more often. In this case, it kind of looks like they're moving faster, but they're not. They're just bouncing around more. They're having more collisions with the container wall.